Okay, so we finally found this bound for f of epsilon, and this bound is for all epsilon positive. Okay. Okay, so if we put all together now, we have that for all t1, comma t2 in 0t, we've got that e of u t2 minus e u t1 is equal to the limit epsilon goes to 0 of e m epsilon ut2 minus e m epsilon ut1, and we know this is the limit when epsilon goes to 0 of integral t1 to 2 of epsilon t dt, and now because of the theorem, dominated conversions theorem, now we can put the limit inside, so we've got t1, t2, limit when epsilon goes to 0, f epsilon t dt. Okay, so you can see here the limit epsilon goes to 0, v is equal to 0. Okay, so this is equal to 0. This means that energy is conserved. We can also say that dte is equal to 0. Okay, so this is the proof of lemma 2, that the solutions of a conservation of energy and of charge. Okay. Okay, so the second step will be to find some bounds. We will first look at lambda positive or equal to 0, and then we will see what happens with the negative, the second part. Okay, so there's a bulwark alternative C of the first theorem. Okay, so let's see the first theorem again. The first theorem told us that we have two alternatives. For t is less than infinity and the limit of ut goes up, or t is equal to infinity. So we're going to find a bound for ut so that we can be sure that this alternative doesn't happen, and so it will have to be that t is equal to infinity. So we want to find a bound of the type ut norm h1 less than equal than a constant that depends on the initial conditions. Okay, so let's assume first that lambda greater or equal than 0. So we will have that norm of minus Laplacian 1/4 ut is less than equal than e of ut, and this will be equal to e of u naught because energy conserves. But let's see why is this. Okay, so this will be because this is equal to, or you can say that this squared is equal to, well, the absolute value 1/2. Okay, 1/4 changes to 1/2. Let's say u transform psi all squared, okay, and this is always in R3. This is equal to psi, okay, and then you transform squared, always a d psi, okay. This is equal to well, not equal, let's say now less than equal than well, the symbol of our operator A, that it is psi squared plus m squared, okay. So this less than equal than that, multiply by u psi squared d psi, and now we will separate this, obtaining, let's say, u transform conjugate psi square root of xi squared plus m squared, u transform psi d psi, which this is equal to the inner product of u a u, and we can see that this is less than equal than e, because when we defined e, let's see where I have e, here I have u a u, okay, I have 1.5, but then we have this also, okay. Because of that 1.5, we can always say that this is within a constant. So we've got that minus Laplacian 1/4, 2 is less than equal than EUT, which is equal to U naught, and we already knew that UT squared was equal to n UT, and we know that charge conserves, so this is equal to n of U naught. Okay, so having this, we can say that the non-UT h1.5 is less than equal than the sum of these two, and this will be okay, within the constant, we can say less than equal than u0 plus m u naught, and this is the constant that we were looking for. So UTH1.5 is less than equal to u naught, then t has to be infinity. We have global solutions. Okay, so why this is true? Just to clarify things. Okay, so let's see first. UT non h1.5 is equal to integral R3 1 plus squared 1.5 absolute value f, well, in this case it's not f, is u side transform, okay, squared d, and let's make some room. What about this? One fourth squared 2, this is squared also, okay? So we already have the definition, is this one, because I want to have squared psi xi squared xi, okay? Well, ut squared, we know that this is integral r square dx, okay? But we can use here Plan-Herald's theorem. Know that this will be also equal to u transform dxi squared, okay? So now we will have that, so it can be seen that this is less than equal than this, the way star 3, psi u psi squared dxi plus u psi dxi, okay? That's how we get this inequality. Okay, so let's start to see the case focusing. It means lambda negative, okay? So without loss of generality, we can assume that lambda is equal to -1, okay? The general case will follow by rescaling. So let's start. I'm going to finish it in this video. We can start with the well, here we have the energy. We will write it as 1/2 the norm of minus inflation plus m squared 1/4 u 2 squared minus 1/4 of integral r3 of u e minus mu x x convolution u squared x, let's say this x u x squared dx, okay? This will be greater than equal than, again the same here, and now minus, I will bound the e minus mu x by 1 u squared x, okay, squared dx, okay? This all will be less than equal than 1/2. We will bound this by multiplication 1/4 u the squared minus 1/4 constant k minus Laplacian 1/4 u squared 2 u squared 2, okay? So in the next video we will see how we bound this integral, what is this k, how we can bound all this, okay?